Hi students, in this video we're going to look at how to determine the equations if we know that lines are parallel or perpendicular. So after watching this video you should be able to determine the equation of a line if it is known that it is parallel or perpendicular to some other line. So some things to recall: first of all, we need to use the gradient intercept of our line, y equals mx plus c. Even if we're given an equation in standard form, for these sorts of problems with parallel and perpendicular, gradient is really important. So we'll always want to get our equation into the gradient intercept form, y equals mx plus c. Some other things that are important to remember: parallel lines never meet. Okay, they never intersect. That's what parallel means. Perpendicular means that lines meet at right angles. And finally, from our last lesson, you'll have to also remember how to determine the equation of a line following those 4 key steps. All right, so the key thing for parallel lines is that, graphically speaking, they're parallel if they have the same gradient. So this first line here has an equation of y equals half x plus 2. This bottom line has an equation of y equals half x minus 3. They have the same gradient. They're never going to meet. Right? Any time that this first line here, this top line, the red one, any time it goes over 2 squares and it goes up 1, the same thing happens with our blue line. It goes across 2 squares and up 1. It's increasing at the same rate, so those lines are never going to meet. So that's why we say that, when graphically speaking, lines are parallel if they have the same gradient. Okay. All right, so now let's use this in an example. So we have to determine the equation of a line that is parallel to 5x minus 2y equals 3, that passes through 14, 2. Now, some of the information we've been given: we've got our point, and we've also been given our gradient, or at least a way to work out our gradient, because we're told that our line here is parallel. So if we think about this being our first line, 5x minus 2y equals 3, the gradient of our second line, the one we have to find, will be equal to the gradient of our first line, because we're told it's parallel. So let's find out the gradient of that first line. We've got 5x minus 2y equals 3, and just rearranging to get y on its own. So we've got negative 2y equals negative 5x plus 3, just subtracting 5x from both sides, then dividing both sides by negative 2. Negative 5 over negative 2 is 5 on 2x, and then that'll be subtract 3 on 2. So the gradient of our first line is 5 on 2. So the gradient of our second line must also be 5 on 2, because it's the same, because these lines are parallel. So therefore, the equation of our new line is going to be 5 on 2x plus some number c. And now this is where we just substitute in our point. So it's going to substitute in 14, 2 into our equation. 2 equals 5 over 2 times 14 plus c. Cancel, cancel. 2 equals 35 plus c. Subtracting 35 from both sides. Negative 33 equals c. Therefore, the equation of our line must be y equals 5 on 2x minus 33. And that's how we can use the information about parallel lines and our point to work out the equation of a line. Now, for perpendicular lines, you might think that the gradient of our second line should just be the negative of the gradient of our first. So looking at these equations here, this one has a gradient of positive half. This red line has a gradient of negative half. Now, looking at those, they sort of look like they're on the right track, but those aren't right angles where they meet here at x equals 5. So it must be something else. So it's not that rule for perpendicular lines. But looking a bit more closely, these lines are now perpendicular. And if we look at this line, it's actually got a gradient of -2. So this gradient of -2 is perpendicular to this line with gradient of +1/2. So the key rule here is, students, is lines are perpendicular if the product, so product means if they're multiplied together of their gradients, is equal to -1. So in this example, m1 times m2, or the gradients of our lines, we had +1/2 times by -2 gives us -1. So these lines are definitely perpendicular. Another way of explaining that is that if we've got a line that has an initial gradient of 3, right, the gradient of our second line is what we call the negative reciprocal. So reciprocal just means we flip our fraction over. So this is 3 on 1, so flipping it over, 1 on 3, and then we make it negative. So the negative reciprocal, we flip our fraction and make it negative. And that's another way of finding perpendicular lines. We would have gotten the same thing if we said our second gradient times 3 equals -1. Divide both sides by 3, m2 equals -1/3. We'd get the same solution whether we rearrange our formula, right? Our formula of m1 times m2 equals -1, sub in and rearrange, or if we know it's the negative reciprocal, flip over your fraction and make it negative. Alright, let's use that for a problem. Determine the equation of a line that is perpendicular to y equals -3x minus 2 that passes through 9, -1. So we're told they're perpendicular, so m1 times m2 should equal -1. Our initial gradient is -3, so substituting that in for m1, -3 times m2 equals -1, rearranging, m2 equals -1 over -3, which is 1/3. And then once again, we know our gradient, we can follow the rest of the steps to find the equation of our line. So y equals 1/3 x plus c, substitute in our point, 9, -1, okay, -1 equals 1/3 times 9 plus c, 1, 3, -1 equals 3 plus c, subtracting 3 from both sides, 4 equals c, -4 equals c, so therefore the equation of our line that is perpendicular to this one is 1/3 x minus 4, and that passes through our point 9, 1. So students, once again, we just have to follow our steps, working out the gradient, subbing it in, subbing in our point, rearranging for c, writing out our equation, the same steps, but how we calculate that gradient is different because we're given information about it being perpendicular. Alright, so after watching this video, you should be able to determine the equation of a line if it's parallel or perpendicular to another line in our problem.